This video covers the review for section 5.4, part 2, graphing polar equations. When graphing polar equations, it always makes it easier to know what the graph is going to look like before you get started. So you can develop this library of what each of these are going to look like and have it on a piece of paper and memorize these kinds of things. R equals 3 cosine theta. We should recognize that as a circle. And the circle and by replacing theta with negative theta, the graph would stay the same. So it has symmetry. Has symmetry about the polar axis. So you run through this list of numbers, theta equals 0, pi over 6, pi over 4, all of our standard angles, and evaluate this function. 3 cosine, let's say polar equation. 3 cosine 0. Cosine 0 is 1, so this is 3. Cosine of pi over 6, or 30 degrees, is root 3 over 2. So this is 3 root 3 over 2. Pi over 4 is root 2 over 2, so that's 3 root 2 over 2. Cosine of 60 is 1/2, so that's 3/2. Cosine of pi over 2 is 0. 3 times 0 is 0. So let's see what we have here. 3 times root 3 divided by 2. In doing these problems, we have to remember that square root of 2 is around 1.4 and root 3 is around 1.7. So 3 times 1.7 is around 5.1. 5.1 divided by 2 is around 2.6. Okay, so we have 0, 1, 2, 3. We have pi over 6 around 1, 2.6. And now we have pi over 4, which is 3 root 2. So 3 times 1.4 is around 4.2. Divided by 2 is around 2.1. So pi over 4, we're at 2.1. And then at pi over 2, we get back to 0. So we're seeing that this is the top. I didn't put my 3/2 on there. My pi over 3 3/2. 1.5. That's the top part of the circle. Now, when we get to 2 pi over 3, this is when cosine starts to be negative. That's 60 degrees, or negative 1/2. So this is negative 3/2. So what's nice about this sort of thing is that you start to see all the same values come about. 3 pi over 4 is negative root 2 over 2, or negative 3 rad 2 over 2, giving us negative 2.1. Same thing for pi over 6, 5 pi over 6, this is negative 2.6. And then cosine of pi is negative 1, so this gives us negative 3. All right, so we're at 2 pi over 3, negative 1.5. So you see the symmetry about the polar axis there. 3 pi over 4, negative 2.6. Pi, I did not do the 3 pi over 4 is negative 2.1, and then this one is negative 2.6. There we go. And so then pi gets us back to negative 3. So in this case, we get the full circle in from 0 to pi. We don't have to go any further than that. Letter B, r equals 2 plus 2 sine theta. This is what we call the heart-shaped cardioid. When a over b is 1, 2 over 2 is 1. You get this heart-shaped cardioid. And the sine has symmetry, as we will see. This one has symmetry about the line theta equals pi over 2. You wouldn't know it by plugging in and doing the symmetry test, but just by what we'll see with the graph. So sine of 0 is 0 times 2 is 0. We get 2. Sine of 30 is 1/2. 1/2 of 2 is 1 plus 2 makes 3. Sine of pi over 4 is root 2 over 2. The 2's cancel. We have 2 plus root 2. And that's around 1.4 plus 2 is 3.4. Sine of pi over 3, or 60, is root 3 over 2. The 2's will cancel, and we have 2 plus root 3. Remember, root 3 is about around 1.7, so this gives us 3.7. Pi over 2. Sine of pi over 2 is 1 times 2. 2 plus 2 makes 4. All right, so let's see what we have so far. At 0, we're at 2. At pi over 6, we're at 3. At pi over 4, we're at 3.4. At pi over 3, we're at 3.7. At pi over 2, we're at 4. All right, so now knowing that the sine of 2 pi over 3 is the same as pi over 3, they're both positive, root 3 over 2, we're going to get 3.7 for this one. We're also going to get 3.4 for this one, and 3, and then the sine of pi is 0. 2 times 0 plus 2 gets us to 2. So this is why we see we have symmetry about the line theta equals pi over 2. So we have these same points on this side. Okay, so there's the top portion of it. Now, when we get to 7 pi over 6, they're not going to be those same values above, because this is where sine starts to turn negative. So sine 7 pi over 6, that's the sine of a 30 degrees, or 1/2, but negative 1/2 of 2 is negative 1 plus 2 is 1. So this time we're going to be subtracting. This one's going to be 2 minus root 2, or 1 minus 1.4. 2 minus 1.4 is 0.6. 4 pi over 3 is going to be 2 minus root 3, or 2 minus 1.7 is around 0.3. Sine of pi over 2 is negative 1, so negative 2 plus 2 is 0. This is why we get the heart-shaped cardioid, because it goes back to 0. At 7 pi over 6, we're at 1. At 5 pi over 4, we're at 0.6. At 4 pi over 3, we're at 0.3. And it gets back to 0 in here. It gets back to its pole. Now, because of the symmetry, we're going to get these same numbers again. So at 5 pi over 3, we're at 0.3. At 7 pi over 4, we're at 0.6. 11 pi over 6, we're at 1, giving us our heart-shaped cardioid. R equals sine 2 theta. When we have the sine of 2 theta, this is what we call a rose curve with 4 petals. This one can be shown to have symmetry about the pole. If I change r to negative r, theta negative theta, we will see symmetry about the pole. So we can use that symmetry to complete this graph. So let's go through this. Sine of 2 times 0 is sine of 0, which is 0. Sine of 2 times pi over 6, that's sine of pi over 3, which is 60. So that gives us root 3 over 2, which is 1.7 divided by 2. Sine of 2 times the pi over 4. Sine of pi over 2 is 1. Then we get to pi over 3, or sine of 2 pi over 3. That's 60 in quadrant 2, so that's positive root 3 over 2. We get around 0.85 again. And then pi over 2, or sine of 2 times pi over 2 is the sine of pi. This gets us back to 0. So I'm going to make this, blow this up a little bit. 1, 2, 3, 4 is going to be my 1 right there. So we start off with 0, 0. Pi over 6 gave us 0.85. And so this 0.25, 0.5, 0.75, so it's about out there. And then pi over 4 gave us 1. And pi over 3 gave us 0.85. All right, so this R went from 0 all the way out to these numbers, so it's got to start down here and go up, and then it gets back to 0. Now sine of 2 times 2 pi over 3, that's the sine of 4 pi over 3. That's negative rad 3 over 2. Negative 0.85. So at 2 pi over 3, we're at negative 0.85. So remember, we started off at pi over 2, 0, and then ended up at 2 pi over 3.85. So the graph is looking like this. 3 pi over 4. Sine of 2 times 3 pi over 4 is the sine of 3 pi over 2. That's negative 1. Sine of 2 times 5 pi over 6, or the sine of 5 pi over 3, that's negative rad 3 over 2, or negative 0.85. So at 3 pi over 4, we're at negative 1, and then we're back at another 0.85. And then pi, sine of 2 pi is 0. We are back at 0. Sine of 2 times 7 pi over 6, that's the sine of 7 pi over 3, which is positive rad 3 over 2, 0.85. The sine of 2 times 5 pi over 4 is the sine of 5 pi over 2. Sine of 5 pi over 2 is 1. Sine of 8 pi over 3 is root 3 over 2. And the sine of 2 times 3 pi over 2 is the sine of 3 pi, which gets us back to 0. Okay, so now we're in quadrant 4, if you will, and we're at 7 pi over 6 became 0.85. 5 pi over 4 became 1. 4 pi over 3 became 0.85, and then back to 0. So we should be able to see where this is going. Now we're going to get into sine being negative. So at 5 pi over 3, it's negative 0.85. And sine of 2 times 5 pi over 3, or 10 pi over 3, is negative 0.85. And the sine of 2 times 7 pi over 4, that's the sine of 7 pi over 2. Should be negative 1. And then the sine of 11 pi over 3 is negative 0.85, and the sine of 4 pi is back at 0. So we're down here in quadrant 4, if you will. 5 pi over 3 is 0.85. Around there. At 7 pi over 4 is negative 1, and 11 pi over 6 is 0.85. finishing off the 4-leafed or 4-petal rose. Letter D, 2 plus cosine theta. There's a whole class of these graphs where you have A plus B cosine theta or A plus B sine theta. And in this case, with the 2 and the 1, what we end up getting is a lemacon, I think it's called lemmason, with no dimple or inner loop. So it does something, it looks almost like a circle. All right, so cosine of 0 is 1 plus 2 makes 3. Cosine of pi over 6 or cosine of 30 is root 3 over 2. So we have 2 plus root 3 over 2, which is around 2.85. You have to remember that root 3 over 2 is around 0.85. Cosine of pi over 4 is root 2 over 2, which is around 0.7. So this gives us around 1.4 divided by 2 is around 0.7. So this gives us around 2.7. Cosine of pi over 3 is 1/2 plus 2 makes 2.5. Cosine of pi over 2 is 0 plus 2 makes 2. Now the cosine turns negative. Cosine of 2 pi over 3, that's negative 1/2. 2 minus 1/2 is 3/2, or 1.5. Cosine of 3 pi over 4 is negative rad 2 over 2. 2 minus rad 2 over 2 is 2 minus 0.7, or 1.3. And 5 pi over 6, cosine of 5 pi over 6 is negative rad 3 over 2, or 2 minus 0.85 is around 1.1. We don't need to be exact, just close enough. Cosine of pi is negative 1. 2 minus 1 is 1. All right, so now we'll start to see this thing take its shape. 0 is at 3. Pi over 6 is at 2.85. Pi over 4 is around 2.7. Pi over 3 is around 2. Let's make that look a little better. 2.85, 2.7, 2.5 is going to be halfway. And then we get to pi over 2, we're at 2. Then 2 pi over 3 is at 1.5. 3 pi over 4 is at 1.3. And 5 pi over 6 is at 1.1. And pi is at 1. And so at this point, changing theta to negative theta, the graph would stay the same. So we have symmetry about the polar axis. So that just means that all of these points are going to repeat. 7 pi over 6 is going to be 1.1, 1.3, 1.5, 2, 2.5, 2.7, 3.85, and 3. So I can just translate these points This is a 2.85, by the way. And so we can finish off this lemicon with no dimple, no inner loop. One plus 3 sine theta this one is a lemicon with an inner loop. And so the lemicon with an inner loop looks something like this. And so it has symmetry about the line theta equals pi over 2. All right, so theta equals 0, sine of 0 is 0, so this just gives us 1. Sine of pi over 6, that's 1/2 or 3/2. 1 plus 3/2 is 5/2. Pi over 4, that's root 2 over 2. 1 plus 3 times root 2 over 2 gives us around 3.1. Sine of 60 is root 3 over 2. 3 times root 3 over 2 plus 1 is around 3.6. Sine of pi over 2 is 1 times 3 plus 1 makes 4. So we see we're going from theta equals 0, r equals 1, theta equals pi over 6, 2.5, theta equals pi over 4, 3.1, theta equals pi over 3, 3.6, and theta equals pi over 2, 4. All right, so now the way that sine works, these values are going to repeat themselves in the quadrant 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. So we get these same values over here, just reflect them. Into quadrant 2. Now quadrant 3 is where things are going to be subtracted. All right, 7 pi over 6. Sine of 30 is 1/2. That's negative down there, though, so that's 1 minus 3/2. This one's going to be negative 1/2. So we see immediately that when we get to this region here, from pi 1, we get 7 pi over 6, negative 1/2. Now that means it's going to be in quadrant 1 up here at 1/2. So, but think about this. This went from positive 1 to negative 1/2, which means it had to go down from 1 to negative 1/2. It had to pass through 0 somewhere. So somewhere between this pi radians and 7 pi over 6 radians, or 180 degrees and 210 degrees, it was a positive. So it's got a little bit of it spent a little bit of time down here first before it went through the origin to this spot there. Sine of 5 pi over 4 is negative rad 2 over 2. So this is 1 minus 3 rad 2 over 2, which gives us around negative 1.1. So at 5 pi over 4, we're at negative 1.1. We can see that inner loop taking shape now. At 4 pi over 3, that's 1 minus 3 rad 3 over 2, which is around negative 1.45. 3 pi over 2, sine of 3 pi over 2 is negative 1. 1 minus 3 is negative 2. So 3 pi over 2, we're at negative 2. And we've got half of that inner loop taking shape. And now the symmetry takes over, negative 1.45, negative 1.1, negative 1/2. And then sine of 2 pi is 0, getting us back to 1. So at 5 pi over 3, we're at negative 1.45. 7 pi over 4, we're at negative 1.1. 11 pi over 6, we're at negative 0.5. And then the negative 0.5 had to go through 0 to get back to 1. That's what tells us that this graph is going to spend some time being positive in quadrant 4, giving us that little last part down there in quadrant 4. Okay, again, that's a lemicon with inner loop. Letter F, very similar, 1 minus 2 cosine theta. This is also a lemicon with inner loop, but this has symmetry about polar axis. And as we're going to see, because the negative's in front of that, it's going to, the symmetry about the polar axis, it's going to be on the other side. All right, cosine of 0 is 1. 1 minus 2 is negative 1. Cosine of 30 is root 3 over 2. 1 minus root 3 is around 0.7. Pi over 4, cosine of pi over 4 is root 2 over 2. 2's cancel, we have 1 minus root 2. Root 2 is around 1.4. So 1 minus 1.4 is around negative 0.4. Cosine of 60 is 1/2. 1/2 of 2 is 1. 1 minus 1 makes 0. Pi over 2. Cosine of pi over 2 is 0. So this gives us 1. So let's see this. 0 is at negative 1. I chose to blow this one up a little bit and make every 2's go by 1. All right, so that means angle 0, over here negative 1. At pi over 6, we're at negative 0.7. At pi over 4, we're at negative 0.4. At pi over 3, we're at 0. But at pi over 2, we're at 1. So that means between pi over 3 and pi over 2, we had some positive r's there, which means the graph is going to spend just a little bit of time in quadrant 1. Look like that. And then between pi over 3 and pi over 2, it had a positive r. So we're getting that loop inside that. All right, 2 pi over 3. Cosine of 60 is 1/2. Negative 1/2. So that becomes negative 1/2 times negative 2 is 1, plus 1 makes 2. 3 pi over 4. That's going to be root 2 over 2. So that's going to make us have 1 plus root 2, which is 2.4. 5 pi over 6. That's going to be 1 plus rad 3. So that's going to be about 2.7. Pi. Cosine of pi is 0. And 1 minus 0 is 1. Wait a minute, cosine pi. -1. Cosine of pi is -1, so that's 1 plus 2 makes 3. All right, so let's see this one. 2 pi over 3 is 2. Three pi over 4 is 2.4. 5 pi over 6 is 2.7. And pi is 3. All right, so now knowing that there's symmetry about the polar axis, when we start putting these numbers in here, it's going to be cosine of 7 pi over 6, which is going to be negative rad 3 over 2. This is going to be another 1 plus rad 3. So this is going to be 2.7. This one's going to be 2.4. This one's going to be 2. This is going to be 1. It's going to be back at 0. 7 pi over 4 is going to be negative 0.4, negative 0.7, and negative 1. Using symmetry, we can finish this graph off a little bit faster. And 3 pi over 2 being 1. From 1 to 0, it's going to stay positive in this region. And then we're going to get the other part of the loop. 7 pi over 4 is negative 0.4. 11 pi over 6 is negative 0.7. And 2 pi is back at negative 1, finishing off the inner loop. And then r squared equals cosine 2 theta. This one's a little bit harder because the r squared, but the cosine of 2 times 0 is cosine of 0, which is 1. So that says r squared is 1. Theta equals pi over 6. That's cosine 2 times pi over 6, or cosine pi over 3. That's cosine of 60, which is 1/2. So remember, when you have r squared equals 1, you have r equals plus or minus 1. R squared equals 1/2, you have r equals plus or minus 1 over rad 2, or plus or minus rad 2 over 2. Pi over 4, we have cosine of 2 times pi over 4, or cosine pi over 2. That's 0, so that just, r is equal to 0 in that case. When you start putting in pi over 3, that's the cosine of 2 pi over 3, which is negative. So we don't get any points for that one. When you put in pi over 2, r squared is cosine pi. Cosine pi is negative 1. We also don't get points for that. Theta equals 2 pi over 3. R squared is cosine of 4 pi over 3. That's in quadrant 3 now, and this is a negative 1 as well. 3 pi over 4. R squared is cosine 2 times 3 power 4, or cosine of 3 pi over 2, and this puts us back to 0. All right, now we're looking at 5 pi over 6. R squared is cosine 2 times 5 pi over 6, or 5 pi over 3. So this is where R squared becomes positive again. 1/2, or R is equal to plus or minus square root of 2 over 2. Remember, root 2 over 2 is around 0.7. And then lastly, cosine of 2 times pi. Cosine of 2 pi is 1. We have plus or minus 1 again. Okay, so with theta being 0, let's make every 4 be 1. 1, 2, 3, 4. With theta equals 0, we got 1, but we also got negative 1. With theta equals pi over 6, we got root 2 over 2, which is around 0.7. So this is 0.75, it's a little bit smaller than that. At pi over 4, we got 0. So this graph doesn't make it past that pi over 4 mark. But remember, we also got the negatives of those. So pi over 4 0, and pi over 6 negative 0.7. And then got back to 0. So we're looking at this. Now, remember, this one has all of the symmetry. This is symmetric about everything. So this is in particular, this is symmetric about the polar axis, which means that we just translate these points and get the rest of the graph. And so that's what the graph of R squared equals cosine 2 theta looks like. Call that the lemniscate. And this concludes the video for section 5.4, review part 2.